Hello wonderful person, this is Anton, and today we're going to be talking about some really revolutionary research when it comes to understanding the phenomenon known as magnetoreception, or basically the idea behind this sixth sense, the sense of magnetosphere, being able to feel the magnetic field of planet Earth. And in the last few years, and more specifically in the last year or so, there's been a lot of new discoveries and a lot of really exciting research that actually is taking us closer and closer to helping us understand how all of this works, and also helping us understand why some people seem to be able to do it as well. Anyway, so let's talk a little bit more about this, and more specifically this study from Japan that was released very recently that helps us understand the chemical and also even quantum mechanical principles that result in the ability of various animals and various cells on the planet to actually feel this magnetic field. But let's start with the basics. Today we know that various animals on the planet are able to perceive the magnetic field, such as the wonderful birds known as pigeons. Some people love them, some people hate them. I'm personally sort of in the middle. But anyway, so pigeons we know feel the magnetic field so well that they can actually orient themselves across the planet and easily find their way back home from anywhere on the planet. You can hypothetically release a pigeon anywhere on Earth and it will always find its way back. But in the last few years we also discovered that it seems that dogs can also feel magnetic field and have a preference for certain locations. For example, they have a preference for which way they sort of sleep. And more unusually, they also seem to have a preference for which direction they tend to orient themselves when they're pooping. And there are lots and lots of other animals that are able to do all of these wonderful things using the magnetic field, including of course sharks, whales and so on. But some of the recent studies have also discovered that certain people, and possibly even most people, seem to be able to orient themselves using the magnetosphere as well. One experiment that I discussed in one of the previous videos that should be popping up at some point somewhere above my head is a really interesting experiment where a hungry person was able to find the location of a sandwich based on nothing else but the clues from the magnetic field itself. In other words, they had some kind of an internal compass that pointed toward the location of food when they were hungry. Not everyone was able to do this, but a lot of people were quite successful in being able to perceive this field. And this of course makes sense because of all things that our planet Earth had for a very long time, something that hasn't changed very much is the magnetic field. So being able to perceive magnetic field by various types of life, evolutionary makes total sense. But the question is, how does it work and why do some animals feel it, yet others are not really good at it? And unfortunately, even today, the origins of magnetoreception in animals is not really that well understood. There are several potential explanations, but no specific one explanation that seems to work for everyone. It's even been called the biggest mystery in sensory biology of 21st century, mostly because it's definitely there, but we can't really explain it. But a lot of the explanations from other animals do rely on this protein right here known as the cryptochrome. It's a protein that's sensitive to certain types of light, it's also sensitive to the magnetic field, and we happen to have it inside our eyes. So that's one of the potential explanations for how we possibly feel it. The other explanation involves this mineral right here known as magnetite, and this is the crystals that are often present in iron inside various animals. And we know that it can easily detect magnetic field because it's basically magnetic, but once again we don't really have a very good mechanism explaining how all of this works for everyone. Especially because we as humans seem to possess both, and so it's not entirely clear which one works for us and which one works for other animals. But last year, some major discoveries were made in regards to the magnetoreception of third type through a magnetic bacteria. Basically, bacteria that we often refer to as magnetotactic bacteria that are able to feel magnetic field and are able to orient themselves towards certain locations. And the way they do this is by using this very long chain of magnetic structures known as magnetosomes that are often present in many different magnetotactic bacteria. And in the last few years, specifically since 2017, a lot of scientists have been actually thinking that maybe this is exactly how various animals are able to detect the magnetic field, through some kind of a symbiotic relationship between the organism and the bacteria. At least for larger animals, like for mammals, for possibly whales and dolphins, and maybe even for humans. And at least one study that you can find in the description has actually been able to positively present the symbiotic relationship between bacteria and other organisms. In this case, it's actually protists. And here the bacteria is indeed used by the protists to orient and navigate, which is actually a very interesting proposition because it means that maybe this is indeed what's happening inside larger organisms as well. And because some of these bacteria have already been discovered inside larger organisms, even humans seem to possess them, it kind of makes sense after all. But obviously a lot more proof is needed before we can definitively say that if this is what's happening here. And so which of these is the real explanation is still not really well understood. It could be the cytochromes, or some of the derivatives of these proteins, it could be magnetite, or it could be the bacteria themselves. But this beautiful animation produced by the scientist whose paper you can find in the description might have actually provided a few hints on what's really happening here. More importantly, they provide a very important explanation to how magnetic field can influence cells and their magnetoreception. So here's what the scientists did and here's what they were studying. There are certain molecules known as flavins that are actually a subunit of a larger cytochrome that tend to produce fluorescence of certain color when blue light is shined on them. And so by first shining the blue light at those cells, the scientists were then able to observe the fluorescence effects from the cytochromes inside the cell. But at the same time, they also changed the magnetosphere, or the actual magnetic field, of the region where the cells were located. And so they were basically turning on and turning off the magnetic field every few seconds. And interestingly, what they observed is that every 4 seconds, it seems that the actual reactivity or the fluorescence effect diminished by about 4%. And that means that the magnetic field sort of slowed down and changed the chemical reactions that these flavins were undergoing inside the cell. Without the magnetic field, the reaction proceeded normally. With the magnetic field, the chemical reaction was much slower. And although at first it wasn't really clear on what's happening to the cells, the scientists now actually have a pretty good explanation to what they're observing and why this is happening. And all of this starts when the light itself excites the electron in one of the flavin molecules and essentially creates these so-called radical pairs. Essentially, it's two molecules that are sharing one electron that are a lot more reactive than other molecules. But here, this is where the quantum mechanics come into place as well. We know that electrons have this other property known as spin. An electron can be either up spin or down spin. And when the electrons in radicals have the same spin, they actually seem to have much slower reaction, whereas the electrons with the opposite spin seem to have much faster reactions. And we also know as a fact that spin can be influenced by the magnetic field. In other words, the magnetic interaction can change the electron spin, making the reaction either faster or slower. Suggesting, of course, that the magnetic effects here seem to influence the chemical reactions. So by having the magnetic field, the chemical reactions slow down. Whereas by having no magnetic field, the reactions proceed much faster. And interestingly, not a lot of magnetic field is required. The total strength of the magnets used in this study were equivalent to a typical fridge magnet, approximately 25 millitesla. Although Earth's magnetic field is much weaker, it's approximately 500 times weaker, and this obviously means that the Earth would not influence the chemical reactions to such an extent. But nevertheless, the effect is still there. And this can also serve as a very good explanation for how various animals, including of course birds, can use magnetic field to navigate planet Earth. Now, many studies came out in the last few years trying to explain all of this, but right now, this is really the only study that actually physically shows how all of this works and how the chemical reactions seem to change with the magnetic field applied. Now, this of course gives a little bit more credence to the theory that suggested that cytochromes are the ones responsible for the idea of magnetoreception in various animals, but it could also explain how this might work in certain bacteria as well. In other words, by being able to show how the magnetic field influences chemical reactions inside various cells, the scientists identified a very important clue to how magnetic perception might actually work in all animals: chemical reactions. It seems to affect the speed of chemical reactions based on this idea of changing the spin of the electron and thus changing the reactivity of certain electron pairs. But despite these really interesting discoveries, this is still not really a definitive answer and not really a perfect explanation. We still, for example, have no idea how these chemical changes and how these reactions then influence the idea of perception in various animals, such as birds. But at this point, it looks like all of this is just a matter of time before we're finally able to explain everything and understand exactly how magnetoreception works in various animals. It might actually have different functions and it might also have different explanations, but we are more or less interested in mammals and more specifically humans. We really just want to know why some people can sense it and, even though unconsciously, some people can't. And obviously it would be really good to find out one day if there's a way for us to actually develop this sense as well. But that's of course something we'll probably explore in some of the future videos once more studies come out and once we have a better idea of what's going on here. Until then, thank you so much for watching, subscribe if you still haven't, check out the studies I mentioned in the description below, and maybe share this video with someone who loves learning about space and sciences. Maybe come back tomorrow to learn something you might have not known, and maybe support this channel on Patreon or by buying the wonderful person t-shirt you can find in the description below. I'll see you tomorrow, space out, and as always, bye bye.